Hello everybody, I hope you're doing well. We're going to continue looking at the 2006 Fryer contest in this video. We're going to be looking at question number 2 right now, so let's take a look. It's a 3-part question with a fair bit of preamble here. So Dimitri has a collection of identical cubes. Each cube is labeled with the integers 1 to 6 as shown in the following net. So it's just like a dice. Okay, 1 is opposite the 6. 3 is opposite the 4, 5 is opposite the 2. Okay. If you wanted to, I think you're allowed to bring dice, which are occasionally pop up on questions. I think you're allowed to bring dice in to the contest paper as it's being written. Certainly in this year there was no preamble telling you couldn't, and sometimes it's helpful to bring little props like that in. Alright, so he forms a pyramid by stacking layers of the cubes on a table as shown, with the bottom layer being a 7 by 7 square of cubes. 7 by 7, this one's a 5 by 5, this one's a 3 by 3, and this is a 1 by 1. So A part, determine the total number of cubes used to build the pyramid. Explain how you got your answer. Okay. Well, there's 4 layers of cubes, top, and then the second layer, third layer, and the bottom layer. And we know how many cubes are in each layer. 7 by 7 layer, 3 by 3, a 5 by 5, and the 1 by 1 layer. So we just need to add those up. So we got third layer, fourth layer. Five by 5 and 7 by 7. So we just need to add these guys up, and you can either do that by hand or with your calculator. 9, 25, 49, we get a total of 85. Sorry, not 85, 84. Alright, 84 cubes in total. Alright. Now there's more to this question, so let's get ourselves another piece of paper and take a look at B part. How many faces are visible after the pyramid is built and sitting on the table? Okay. So you notice here this top cube, even though we can't see it because it's a 2D image, everything except its bottom face is going to be visible. And then if we take a look at the third layer, we have these corner pieces. They have 3 sides visible, but each of these side pieces only has 2 sides visible. The other sides of the cubes are hidden. And of course the thing is sitting on a table, so we don't need to worry about the underside of the bottom layer. So once again, on the bottom layer we'll have 3 visible on each corner. And then we'll have any cube along the side will have exactly 2 faces visible. Okay. So how best to do this? Can we draw the picture? That's a good question. Should we draw the picture even? Picture drawing not going so well, so we may have to abandon it. but we'll give it one more shot. Nah, no, I'm not going to draw a picture. I will just have to describe it using words, which is perfectly fine. Okay. So we'll just go layer by layer. And describe what happens. In the second layer, so that's the first and second layers. How about the third layer? So there's 4 sides to the square that makes up the third layer. Now it's a 5 by 5, but we don't count the corners. So we get 12 cubes on the side showing 2 faces, and we can double check that with the picture. So here we are on our third layer. 1, 2, 3, and all the way back here 4 corner cubes, and then 3, 3, 3, 3, so 4 times 3, which is 12 side cubes, each of them showing exactly 2 layers. Okay, and then we just have one more layer to go, that bottom layer, and it's going to have 4 corner cubes, and this time 7 minus 2, which is 5 side cubes on each side, so a total of 20. So we can put all this into a little chart. Remember, we're counting the number of visible faces. So we either have 2 faces showing, 3 faces showing, or 5 faces showing. How many cubes have each? So in the first layer we have just the 1 showing 5. In layer 4 we have 4 corner cubes showing 3. And we have 4 side cubes showing 2. Then in the third layer we have 4 more corner cubes. In the fourth layer we have 4 more corner cubes. So a total of 12 faces showing exactly 3 sides. 12 cubes showing 3 faces. Sorry. And in the third layer we have 12 side cubes showing 2 faces. And in the last layer we have 20 side cubes showing 2 faces. So that gives us a total of 36. So we add up, this is the number, this is the frequency, so we multiply them together and add them up. So that's 36 times 2 plus 3 times 12, which is another copy of 36, plus 5. So we have 113 visible faces. Okay. And if we wanted more layers, we could try and generalize. I mean, we already know there's always going to be 4 corners. And in terms of side cubes, we have a formula for that. 4 times the side length minus 2. So we can definitely keep going on with this. But let's take a look at what C-part asks. So we have 113 faces visible after the pyramid is built and is sitting on the table. That's fine. C-part, explain in detail how he should position the cubes so that if all the visible numbers are added up, the total is as large as possible. What is this total? Okay. So each cube is placed independently. So we don't, I mean, the position of one cube doesn't really affect the position of the other cube. So what we're going to try and do is maximize the total possible shown. So one cube has 5 faces shown. We want to maximize that situation. We want to maximize each of these 3 corners being shown. So what, according to this net, what set of 3 faces meeting at a corner gives us the largest possible sum? And each of these side faces, what pair of faces up here sharing an edge? So maybe it's 1 and 5, or 2 and 3. We have to take the net into account. What gives us the largest possible face value? And then we can duplicate that for each cube showing 2. So it'll probably be very useful to have a copy of the net on hand, so we don't have to keep going back to it. So we had a 6 here, a 5 here, this is a 3. I'm going to make that 5 a little more clear, because sometimes my 5s look like 3s, which I do apologize for. We get a 2 down here, a 1 here, a 4 here, and let's make this 5 really good. That's a pretty good 5. Not the best 5, but it doesn't look like a 3, which is the point. So if 2 faces are shown, it's always shown the same way. That is, those two faces share a common edge. Five and six, I mean, that's the largest pair you can have, period. And the fact that they share an edge really helps us. So this tells us how to orient all the faces that are showing exactly 2. So all the side cubes on layers 2, 3, and 4. Now if 3 faces are shown, these are always corner ones. And we don't need to justify this by listing out all possible sums, 3, 5, 6, and 6, 3, 2. 4, 5, 6, I mean, if you want to, you could probably draw the net and maybe circle the corner that they're at. You know, we could circle the corner here. And then maybe we could also highlight the edge in orange if we wanted to. And lastly, if 5 faces are shown, by the way, remember, we're asked to describe how to orient them, and then we're going to be asked for the total sum. So this 5 plus 6 equals 11. That's definitely going to help us. But we also need to mention that 5 and 6 are the ones that need to be visible. And this 4 plus 5 plus 16 equals, this 4 plus 5 plus 6 equals 15. Should be mentioned as well, but also we need to say 4, 5, and 6 are the ones that should be visible on the corners. So we want to hide the one face. We want it to be sitting with 1 on the bottom. And that gives us a total of 20. Let's draw that line a little better. So we have 2 faces shown, or 3 or 5. We have 1 cube showing 5, we had 12 showing 3, and we had 36 cubes with 2 faces being shown. So 36 of the faces are going to show a 5 and a 6. So their total will be 11. 12 faces will have a total sum of 15. And the one face, the face on top, will be showing a 2, a 3, a 4, a 5, and a 6, giving us a 20. So that's 36. We don't need these 2 faces shown. We're not double counting. Here are our 2 faces, a 5 and a 6. So 36 cubes are showing a 5 and a 6. So 36 cubes are showing us a sum of 11 for their faces. So that's a place you might screw up on. Don't include the 2 faces shown. They're being counted in the sum. 12 faces are showing 15, and 1 face is showing 20. So 36 times 11, that's 396, plus 12 times 15, plus 1 times 20, gives us a total sum of 596. So let's just double check that. 36 times 11, plus 20, plus 120. All right, 396. Sorry, 596. So let me. Okay. And that gives us the maximum possible sum. So, we have stated how Dimitri needs to position his cubes to maximize the total possible sum, and we've also been able to calculate this total possible sum. And that concludes the C portion of the question, and that actually finishes up the whole question for us. So that's question number 2 on the 2006 Friar contest. Hopefully you've enjoyed it, and hopefully you remember to try it ahead of time. If not, please remember to try question number 3 before we look at it in the very next video. But we'll see you guys for that question next time.